really cool place, Harlem. Harlem's cool. Harlem's, well, I mean, maybe now.
You know what?
But then,
What? $203 people who prefer checkers over chess. What?
checkers is easier on the mind, but chess.
I hate
best-
checkers.
better
I don't
game.
understand it. I understand
It's
chess
basically
better.
chess.
Okay,
except you jump over things.
So 200 of 550 people, or 203,
And it doesn't
checkers
have a
over
class
chess,
system.
and also not checkers. Well, in 60.
I'm gonna look up how to win.
Okay. Before we do that, though, obviously I encourage you to learn how to tie a necktie. I think that's important. But I don't think it's important for right now.
But we're learning statistics, sir. That's mathematical.
No, I agree. So now, yesterday we talked about the reciprocal trigonometric ratios. Reciprocal trigonometric ratios. What were the three reciprocal ratios?
Right there.
They are right there. That's true. What are they?
Trinity didn't get a handout yesterday.
Oh,
Same here.
Please.
Same
Oh,
here.
I don't know if I have them or not. I may have to print one off for you. Yeah, yes, but if I don't have them, it can wait. We'll get there because we're just going to kind of briefly talk about now. Then I'm going to teach this one question, which again is only one question. Shouldn't take us more than maybe 20 minutes. I said shouldn't, so we'll see. And then I will get those ready for you. So, the whole idea with yesterday's note is just that we have always learned that sine, cosine, and tangent are so katoa. Sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse, and tangent is opposite divided by adjacent. Is there any reason we could not flip those? Is there any reason we couldn't take hypotenuse divided by opposite as a measurement? Of course we could, right? We can do that. And could we not divide hypotenuse by adjacent? Of course we could. We get a number every time. And could we not divide adjacent by opposite instead? And of course we can. We can flip every one of those fractions.
What's the point?
Well, the answer is it is to be complete. Since those are mathematically possible, they decided to give them names.
Okay.
If you're going to run into something, you might as well have a name for it.
What?
That's why I name my children. From time to time, I have to see them. I might as well have something
One
to
and
call
two.
them.
So it's
That's right.
normally
Male
the
child and
second
female
one.
child Orlando.
You normally like
Good
the second
names,
one more
good
than the
strong
first
names.
one.
It's pronounced Male and Famale.
Male and Famale. Those actually kind of sound lovely. Male Orlando and Famale Orlando. Kind of lovely. All right, well, you win. This round goes to you, Dan. Next round, I'll come more prepared.
1-0.
That's correct. All right. So we call them the cosecant, the secant, and the cotangent. That's just what they call them. The nice thing is, if we're ever given one of these numbers, if we're ever presented with them, we don't have to worry too much about them. We don't have to work with them because the cosecant is just the sign flipped. So if we know the cosecant, we can find the sign just by dividing it by 1, or dividing 1 by it, rather. We just flip the fraction. If we know the secant, we can find the cosine just by flipping the fraction, or doing 1 divided by it. If we know the cotangent, we can find tangent just by flipping the fraction or doing 1 divided by it if we've been given the decimal. So in any case, if we know cosecant, secant, or cotangent, the easiest thing to do is simply to express those as sine, cosine, or tangent. Does that make sense? And that's how we deal with them. It's just added one new step to the types of questions we did. So we went through and we did a few examples. And in each case, if I told you the cosecant is -2, the first thing we have to do is say, hey, since my calculator can't handle a cosecant, since we don't have to work with that, I'm just going to flip it to turn it into a sine. So a cosecant of -2 is the same thing as a sine of -1/2. We just flip it. We will have time at the end of class to go over a few examples like this to cover over that note. Today, I just want to look at where this is all headed. So we've learned a whole bunch of new math skills. We've learned about the cast rule. Now, the next bunch of days are just going to be spent doing problems, actually using this stuff to measure things. But there's one more thing we have to watch out for. When we're using trigonometry, what shape do we inevitably make when we, yes, triangles. We inevitably make triangles. And there's one more thing we have to watch out for. We've just learned the cast rule. And today we're going to apply the cast rule in a practical setting. So one question, a lesson in one part. Can't hide from it.
Yeah, I from like I can be.
We should
I don't need a hood to do that.
I will try to move hastily for once in my life.
Man, I know I might as well kill
I
it.
mean, oh, you're right. I can't see a thing.
There we are. So I created this lesson a couple of years ago. I was taking a group of students to a leadership camp for a week. Isn't that adorable?
That's smoking.
That
That's
is
so unhealthy.
He's smoking a pipe. He's a ship's captain. You'd be smoking a pipe too.
Do not promote
The
smoking.
Scots are angry people.
Yeah,
in
That's
this
true.
school.
Okay, so
Already enough of it.
so if the question seems a little bit specific, I just really like the question, so I kept it. But I once worked, and I shouldn't admit to this. I can't believe I'm recording this right now. I should go pause, but whatever. This is true. I once worked with a teacher who needed a day off on a Friday. He was going on a trip, and he was worried that if he called in sick, they'd ask for like a doctor's note or something. He was planning on being out of the country. So he planned with students, this is so terrible, a fake golf tournament where he picked 5 students and said, listen, I really need the day off. So I'm going to say we're at a golf tournament. You don't go to school. I won't go to school. You get a day off. I get a day off. No one has to know.
It'll work.
That is, well, nothing was ever said by admin. That is horribly inappropriate. I happen to think that's theft and fraud and really inappropriate, but it was funny. So he put an announcement in saying how they'd done. He took pictures from a previous day of golf and like put them on his website. Like this guy went whole hog for this fake golf tournament. I thought this was amazing. I just thought that was, again, horribly inappropriate. I don't condone it, but I have to admit, it's funny. It's
And clever.
and brassy, right? Like that takes some boldness that I don't think I possess. I would not have the strength of will to do that and trust that I wouldn't get caught. So anyway, this was mine. So I was taking kids to a leadership camp. So in this, a teacher who shall remain nameless has invented a fake week-long leadership building activity at the school so that he can actually compete in a boat race from Havana in Cuba to Tierra del Fuego, which is the lowest point in South America. It's one of my goals in life. I want to sail along the coast of South America. I find that idea exciting.
Havana is in North America.
It's true, but to get from Havana to the lowest point in South America, you would have to sail along, wait for it, the coast of South America. Apology accepted. So here we are. So this nameless teacher boards his boat. He very patriotically, in support of his school, calls it the Eagle's Talon, and he sails with great enthusiasm and no small amount of talent down the coast. So by 1:25 p.m. on the Thursday afternoon, while his classes suffer through pre-recorded lessons in silent misery, the finish line, which we shall call point F, is 10 kilometers away from his boat, the Eagle's Talon. And I thought it would be fun to,
Oh my God.
yeah, no, I thought if we're going to do this, let's do this. So here's my boat. what's it called? The eagle's talon? We're going to call it. There we go.
You should know your own.
Phone home. And there's the finish line, point F. There we are. How far am I from the finish line?
Half a meter.
10 kilometers. Okay, there we go. But there's another boat. Boo. Called the Bear Paw. My last school is the Bears. Boo hiss, boo hiss.
Esau's connections to the social school. We haven't had a long social school in the same.
Yeah, so it turns out, you know, I'm not the only one with bright ideas. Okay. And how far away are they? Oh, those jerks, they're closer. Okay. So there's a diagram. Does that look good? I'm close to the finish line. They're closer to the finish line. Do I give us any more information? Yeah, what else did I tell you?
48 degrees.
48 degrees, and where is that? Okay, so if I'm standing on the stern of my boat and I'm looking out there, there's 48 degrees between the finish line and the opposing team's ship. Okay. What do I want to know? What's my question?
I feel getting second.
Oh no, I've got a plan. That's a follow-up lesson. It involves cannons. Yeah, I play to win. So, something you should know about me. I don't like to lose. Do you see the kind of ship I'm in? What are these? The cannon ports. I'm just saying. All's fair in love and sailing. So, I'm an originalist. I believe in original. Okay, so here we are. So there's my diagram. And I want you, by the way, we're going to work on the left-hand side of this page because at the end we're going to write some steps out on the right. So let's just try and keep our math to like the left-hand side of the page here. I'm trying to do so in mine. You could even maybe we could draw a line down the middle. I'm going to try and keep my math to this side. Okay, so I want to know D. Could I directly use the sine law to answer this question? What do we think? This is going to be a multi-step one. These are the kind of problems you're going to get this year. We're going to have to do a few steps. If I was going to use the sine law to answer this question to get side D, I'd have to know angle. Yeah, I'd have to know this angle, which I don't. But we can do math to figure it out. Now, I can't figure out angle F directly either with the sine law because I'd have to know side D, which I don't. So I'm going to have to find this angle. But luckily, once I find that angle, all three angles have to add up to 180. Yeah. So the first thing we're going to look for is this angle BP, that corner there, the bottom right. And we're going to use sine law to do it. So you're going to see when we get to the trig questions in this unit, they're actually really fun, but they tend to be multi-step. We tend to have to do a few steps to get them. So how do we set up sine law again? If I wanted angle BP, I could say that sine BP over what? Come on, you trigonometrists. How do we use the sine law again? Sine law, not sine, but sine law. Remember, you've used it. Sine A over A equals sine B over B. I should have used lower cases there, I guess. Equals sine C over C. Cool. Okay, so in this case, the angle BP, its sine will be put over what length from this triangle? 10. Very good. And that's going to be equal to, let's work with the angle I know. What angle do I know? Sine 48. And that's going to be over what? 8. Okay, and how am I going to solve this? Yes, math. we're going to be, yeah, we're going to cross multiply it. So we'd be able to say that sine BP should be equal to what? Who wants to do that? I'm going to hand out some calculators for you. Yes. Oh, perfect. Can you hand me that one, Deborah? Okay, sir.
1 to everyone. May not be enough for everyone. We're missing 1%.
That's okay for the time being. We're down one. Oh, it's on my desk. Okay. What? Any phone?
I'll take it.
There you go. You're welcome. Okay, so how do I cross multiply this? It should be, what, 10 times sine 48? 10 times sine 48, and then divided by what? Divide by 8. Very good. And what do we get when we do that? 0. I want like 4 decimals here. We're going to be fairly accurate. I want to know exactly how far away the competition is. 9289? Great. Okay. If that is the sine, what's the actual angle BP? How would I find that? Cool. And we get 68 degrees. Can I get 1 decimal there? Equals 68.2. Okay. I'm going to keep an extra decimal all the way to the end, and then we'll round it out. Okay, and I'm going to go put that in my diagram, because that's information I know now. In fact, I'm going to highlight it down here and say, hey, 68.2 degrees. I know that. Now, again, I didn't really do that because I wanted that number. What angle am I really interested in? F, yeah, angle F. Now, the nice thing is I can figure angle F out now. How?
180 subtract 48 and 68.2.
Good. So angle F should be 180 degrees minus 48 degrees minus 68.2 degrees. And that should be what?
63.8.
Did you say 63.8? Good. Is that right? Does everyone agree on that? Oh, I should put an F in there. Oh. Okay, so let's go put that in here too. What was it? 63.8? Yeah. Goldfish memory. Cool. Now, if I want to find D, I can just use what law again? Yeah, we can use sine law again. And this time, so now, find D using sine law for a second time. Okay. And what am I going to find? Tell me this. So we're going to say sine of what angle did we just get again? 63.8, and that should be divided by what? Yeah, that should be divided by our distance, and that should be equal to what? You can pick any of the other pairs, doesn't matter. Sine, what was it, 68.2? Divided by what? Good. And then when we go to solve for D, what should it equal? 9.6? 9.6 what?
6.
So we'll call it 9.7. I'm going to go down to 2 decimals now that we're at the end. So I'm 10 kilometers away from the bear paw, outside of cannon range. That's unfortunate. Gonna cut that angle. How do we feel about that answer? I like it. I think it's good. But I want to suggest something.
Oh boy.
What if, what have I here? More ships and more finish lines.
Oh.
What if there's the finish line? Oh gosh, that's not what I meant to do. What if there's the finish line and there's my ship? That's my ship. That's the Eagle's Talon, right? That's what we called it. And there's the finish line. And we were how far apart? "10 kilometers. Oh, I hope I didn't screw this question up making it. It wouldn't be my first time. I make mistakes sometimes. But what if instead of 63.8 degrees here, what other answer could I have got here? See, we said that the sine was 0.9289. And when we took the sine inverse, we said that gave us what angle? Yeah, but what if, just bear with me here, if we know that the sine of angle BP is equal to 0.9289, then angle BP could also equal what? Well, let's do a little cast rule over here. We said the angle it could give us was what, 62.8? Where else could a positive sine live? Yeah, over here, because that's cosine. All of these are positive. Sine's positive here, tan's positive here. What angle would this be? Oh boy. Well, that's a new development. Stop. That's good. I'm glad. I'm glad for your good spelling. Yes?
111.74.
Oh, I'm sure you're right. I'm sure you're right. This would also be 62.8, right? Which would mean that the angle measurement here would be what? 111, and I'm just going to call that 0.7, if everyone's okay with that. How'd we get that?
You just subtract the 68.26 from 180. I mean,
Oh, did I have the wrong number? I have the wrong number. I'm sorry. It should be 68.2, not 62.8. Is that right? Okay, that makes sense. And actually, should be 3. Does it round to 3? Is it 2? Okay, then we're going to say it's 2. And if I'm wrong, so be it. We're going to call that an 8. Okay, so 111.8 degrees. That makes sense. That's the other possible angle. So it's 68.2, or it's 111.8 degrees. Does that make sense? Could we make a triangle with that? Yes. So this is also a possible triangle. Also possible. Does that make sense? We have to be careful here because there's not just one triangle we could make. I'm sorry. We actually could make 2 possible triangles. And for it to work, we have to make angle F be really what? Angle F would have to be what angle? Over here, we made angle F 63.8. It was an acute angle. But F could also be, it could be an obtuse angle. In which case, we would have, and I'm actually going to make the triangle first and then put the symbols, because I'm not very visual and I struggle with this sometimes. So I need one angle to be 48 degrees. Roughly how big is that? Well, Well done, Joe. Roughly like that, right? Does that make sense? And then I need this side to be 10 kilometers, right? Because I was 10 kilometers away. Okay, now I'll put me here. So there I am. There's the finish line. Hey, look at me. But now, this angle needs to be 100, was it 11.8? And those are from the bear paw. There's the bear paw. There's the eagle's talon. What? Are you imagining different types of cookies? Oh, bear paws. Yeah, they're delicious. They're very good. Does this make sense? We can get a different answer to this question. And now, if this is our diagram, now what angle do we get here? It's going to be a different one. What's angle BP now? Ah, crap. Did I make a mistake? This is a thing I do sometimes. See this? Don't be like that. Yeah, sometimes. See, this is why I said I was going to draw the diagram first. I'm sorry. Stop. Stop that. Sorry? Yeah, but I put them in the wrong place. I put them in the wrong place. Okay, so let's try this again. 48 degrees, right? And 100 degrees, right? And then this one, there's our finish line. Sorry? I know. Well, I'm doing my best. Can we all agree I'm doing my best? You try, and I will come and look at yours. I'm not kidding when I say I really do struggle to be visual. So we know that angle BP that we found, it either is going to be, as we drew it here, at 68 degrees, or, hello, it can be 111 degrees. So you draw it, and I will come take a look and then copy it onto mine. This is good. You're seeing struggle in action. I struggle with it too. So I'm going to try it on paper first and then try it on that. To avoid continually embarrassing myself. It does work, I promise. You just have to be smarter than I am, which, listen, it should be very doable for you. Really, it makes sense to start with the 111.
Yeah.
Haha. Fool me once, shame on you. Fool me twice, still shame on you. Fool me that third time, I'm still blaming you. But now, fourth time's the charm. Orlando's got it. All right. You want to know the sad thing? No, the sad thing is I did this 3 times at lunch to make sure I wouldn't do this. I tried it once, screwed it up, said, okay, that's fine, I got it now. Then I wrote it out fresh again a second time, screwed it up, said, okay, that's okay, I got this. Did it a third time, got it successfully. Then I was feeling like, yes, tried this 3 times, now I know it. Then, live and in front of the audience, what did he do? Oh, he dropped the ball. And then he did it again. Every time. You should see me teach blood typing. That's the other one I screw up every time. I don't know why. Every time I've ever taught it. Horrible murder. Okay, so we're going to try here. This is one of those peculiarities of how my brain works. I have to draw this with this orientation for it to make any sense to me, and I don't know why that is. You're not triggered. That's not true. Okay. Okay, there we go. This was the 48 degrees as given. This is 111 degrees. There we go. Oh. Then I was 8 kilometers, or 10 kilometers away. Pardon me. And the bear paw was 8 kilometers away. And the question is, what's the distance between us? There we go. See, I knew I'd get there eventually. So now the angle we want to find is, because it is how much? And how'd you get that? We said that angle F we calculate by doing what? Very good. From? Yeah, so angle F is just going to be 180 minus 111, was it 0.2? 0.8. Degrees and minus 48 degrees. And what's that give me? Angle F equals 20.2. Perfect. And we can go ahead and put that into our diagram. I'm likely to screw it up, but let's try it. I have faith in me now. I feel like I'm back on the wagon. Yeah, sometimes you got to be wrong before you can be right. You know what? If getting the right answer the first time is right, I don't want to be right. Actually, I do. It really does feel good. But sometimes we make mistakes. Listen, I make lots of mistakes. Does that make sense?
Yeah.
I think it was trying to include the pictures that really sunk me, but I don't regret it.
Sunk you?
Oh, I didn't even plan that. But I don't regret it because I think they look quite cute. And it gives me all these nautical puns, which, let's face it, it's worth its weight in gold. Okay, and now that we know that this can be 20 degrees, because this was 111 degrees, now tell me how far apart we are. And if my cannons can shoot 3 kilometers, can I get those SOBs on the bear paw? Let's find out. Yeah, use Sine Law and set it up. See what you get. You want me to, I can tell you the homework if you want it. Okay. Yeah, I'm talking. Oh, that's it. Well, have fun. Dude, that'd be great. Cool. Yeah, I think you're right. And it is online, and the blank copy is online too. So if you have time, you can go online. But if not, it's okay too. No problem. Have a good one. Wait, how did I set this one up? This particular Sine Law. Oh, that's interesting. A little piece of stripping coming off down here. All right, how would I set this up? What angle goes with D now? 20.2? So I would say the sine of 20.2 divided by what? Divided by D. should be equal to, hello.
Hi. This is Mr. Calford's class?
No, Mr. Calvin's class is right next door. You're welcome. Have fun. Math class is fun. What's not fun about math? Sorry? Yeah. I can't wish my colleague fun.
No, I meant like, you came in and said,
Well, I think he knows that I'm not Mr. Kelford, but because he's going in the middle, he's relieving a coverage for the first half. So presumably he was thinking that maybe I was covering the first half and he's covering the second half.
Oh, it just seemed fun.
Oh, really? Just hang out, guys? Because usually they do it in halves, right? Like teacher covers first half and teacher covers second half, which is such an unfair deal. Because second half is great, right? First half, you have to like get them started, take the attendance.
Life's unfair.
Yeah, it's so much work. Oh,
Math.
such a hard life being a teacher.
Not life after 10 years getting paid more than most salary people in Canada.
Well, first of all, I mean, the average teacher has substantially more education than the average person in Canada, right? Well, I mean, you can disagree all you like, but
benefits than any other person in Canada. They get the best
That's actually also
vacations.
that's not nearly false or nearly true.
That's not nearly false.
Like, no, I mean,
And
listen,
also, you
the
get most
vacation
time
thing,
off.
vacation thing is a perk. I do not get the most time off. My wife works 7 on, 7 off. So that's 26 weeks off a year, right? So no, I don't get the most time off. And then within that, she gets 2 lieu weeks. So that's 28 weeks off a year.
Yeah, but what are
My brother-in-law's a firefighter. He gets the same basic 7 on, 7 off schedule, but he's up to 6 lieu weeks off a year. So that's 20 weeks a year of work. No, we don't come anywhere near to getting the most time off of public employees. Well, I know, but like, I mean, it's not even in the realm of close. Secondly, is it a lot of time off on a really sweet schedule? Oh, you betcha. It's a great gig. Teaching weekends. I mean, I don't really get weekends off because I usually spend about 12 hours of it doing schoolwork. But like one day I anticipate like having all these courses totally prepped and I'm going to do nothing all weekend. It's going to be great. Holidays, summers. Yeah, of course. It's a perk. It's a good perk. Nothing wrong with that. But let's be clear. I made about 15 grand more a year doing what I used to do. So, I mean, managing a restaurant. Yeah, so I mean, it's, and I made
That's why you're a new teacher.
And I made almost as much money doing that as I did waiting tables. I mean, I still haven't caught up teaching to what I made as a waiter. I'm getting close. I'm
But-
$2 grand shy this year. So next year I should make more money teaching than I made waiting tables.
But you're a new teacher. Like,
I'm not that new. I'm 7 years in.
But you also don't have a full
Right?
position
It
for
goes
more
by
than one
It takes
year.
us 11 years to hit the peak of our seniority. My wife will hit her peak seniority be at peak pay by year 5. The average cop is at peak pay by year 4. RCMP, it's year 6. You know,
Coloring and everything.
we're doing all right.
1,500 a year.
Listen, and it's the Canadian thing, right? Like our public sector employees, we pay very, very well. Not just teachers, but all of them. Is that a bad
As
thing?
long as you're not a teacher in America.
Yes, because our taxes are too.
Well, but again, like we also pay taxes. My taxes are just as high as yours.
So then I guess the higher pay doesn't really matter because you're pretty much just paying, you're giving yourself money
Yes,
in the end.
but not much of it. Mostly you guys are paying my salary. Well, not you. You don't make any substantial money yet to pay taxes, but one day you will. One day you'll pay taxes.
I didn't get any money back on my tuition.
Really? How much? I'm not gonna ask how much money you made, but that's surprising. You should give some money to charity, man. Come on, get some of those refunds.
You know how
Yes.
much you, well, actually, I was going to say your generation, but technically the 2 generations. You know how much your parents' generation screwed up mine and my future?
Oh, your life is so hard. I feel so sorry for
Yes.
you.
Considering now that
Okay,
we're getting
explain to
seniors.
me how people from the baby boom generation had it hard when they had paid off houses at 20, cars, free jobs that were perfectly accessible and well paying when they were my age.
Listen. Not to get too far into this, but just to be clear, the average person from my generation has greater wealth at my age than my parents' generation did at my age, and that's completely factual. No, accounting for inflation. These things always account for inflation. But also just standards of living. I mean, the middle class is living longer on average, not the poor. That's something else to discuss. Seriously, no, I mean, they have seen none of the benefits of rising age. But the middle class are absolutely living longer than they ever had. People from the baby boomer generation on average had 1 car per family. Is that true of families today, even in the lower middle class? They usually have 1 car per person. You know, 1 little TV that looked like this and got 3 stations per family.
Technological advance.
Sure, you don't think that's valuable?
Yeah.
You want to jump back to the 50s of free TV times and dying 4 years younger?
But TV,
I don't think you do.
I only live there and not necessarily.
Seriously, you look at me right now and say, hey, I'd like to give up the internet, 4 years of my life, television shows that I find interesting to be replaced with Leave It to Beaver, and I'd like to give all that. I'd like to give all this stuff up and all the accoutrements of modern life, and I'd like to go work in a factory for my whole life, and sure, and have that as a lifelong employment. I don't think most people who talk about the wonders of the previous generation would actually want to switch places and live in those previous generations. Let's add to that the imminent threat of two countries that were actively engaging in nuclear proliferation. Sorry?
It's now we're gonna die real soon.
I don't think we are going to die real soon. I think, listen, if the 20th, and let's add to that, if you're an American in that time, you've got 2 wars that you can be drafted into. That'd be fun. Vietnam. That was just a few 100,000 deaths. What's wrong with that?
It wasn't a few 100,000 deaths. It was 56,000.
Oh my god.
Oh, I see. Vietnamese people don't count. That's an interesting thing to take note of. I'd make the argument that they do, but we'll move on. Yeah. No, I'm going to get back to that.
Like if you actually use folks back to the triangle. Then you can rant. I just want to see the triangle.
Oh, I'm such an awful teacher. It's so
Also, by the way,
sad.
Never mind.
Actually, second 40.
No, because you have to count in the introduction time, which wasn't doing the question.
It was after my question.
I need help. I can't read numbers. I can't read.
Anyway, long story short, for all you talk about, I don't think you have to all that.
What if I actually go back in time and live that age with the knowledge I have
Well, we've
now?
said before. We've had the specter of this conversation.
Which spectrum? Give me the
Hey,
exact.
listen, I get it. My generation has the worst employment rate of any generation ever for entry-level stuff, but we still
And we have the higher
money.
tax now because we're gonna have to pay for the baby boomers going to retirement homes.
That
We have
is
to
true.
fund them.
Not in his. Don't listen to him exactly.
Okay.
However, it's true.
Let's just tell me taxes.
Those baby boomers have been paying payroll taxes their entire lives. What?
And
We should throw them out?
Yes.
That's ridiculous.
They're not beneficial to society anymore. Goodbye.
Wow.
Y'all are sick.
Whoa.
Okay.
Wow, that's it's a good thing. It's a good thing you're so beneficial. It's a good thing you're so beneficial to society right now, Andrew.
Yeah.
I am.
I was just
popcorn and I cash out for groceries.
I was just thinking. Listen, let's never forget that every one of our jobs could be replaced by a computer if we had the political will to do so. Now, back on to what we're doing. I'm pathetic. Okay, let's keep going with this. Sine 20. No, I've known for a while. Sine 20.2 divided by d, and then give me another pair. What did you use? 111, and that was 0.8 or 0.2. I can't remember. Okay, divided by 10. Okay, and we're going to cross multiply this, which works how? It does work by math. That is very true. And we would get d equals what? Yeah, we have 10 times sine 20.2. It should be divided by sine of 111.8. Does that make sense? And when we do that, what do we get for d? 3.7? You got lots of time. Still not going to make it, but that's okay. So I'm going to lose the race. Point being, I can give you all the same parameters for the question, and how many answers can I get? 2. And they're radically different. They're radically different answers. The diagram on the right does not look like the diagram on the left. 2 different setups. They both satisfy the conditions, the parameters of the question as I gave you. Does that make sense? Yeah, please. No, just don't. I would give no pass.
Basically, invest in Google.
So awful.
Except,
So the takeaway today is that we call this the ambiguous case. What does it mean for something to be ambiguous?
Unknown.
Yeah, unknown, unclear, not definite. So in a certain situation, you can end up getting two possible answers that work. Now listen, what law did we use in this example where we ended up with an ambiguous case? Sine law. Could I have an ambiguous case in the cosine law?
maybe.
What do you think? Could I have an ambiguous question like this using cosine law?
Yeah.
What do you think? How did we end up with this? Remember, we went to the cast law, or the cast rule, and we said that we could either end up with 68.2 or 111.8 because there's two places that sine can be positive, right? Sine can be positive in quadrant 1, because everything's positive in quadrant 1, and sine can be positive in quadrant 2. And those angles in quadrant 2 are all between what? In quadrant 2, all the angles are between 90 and 180. And can you have angles between 90 and 180 in a triangle? Sure, we call those what kind of triangle if they have an angle between 90 and 180? Right? Obtuse. So that's possible. You can get an obtuse angle, which is allowed for triangles. If we use the cosine law, it would give me one angle between 0 and 90, which could be real, and then it would give me another angle between, that would be down here. But what about down here? Cosine. Those would be between 270 and 360. So if we use the cosine law, it's still going to give us two answers, but one would be between 0 and 90, and one would be between 270 and 360. Could the angle between 270 and 360 ever be right for a triangle? No, because all the angles in a triangle have to add up to 180.
I don't know, it seems right from this perspective.
What do you mean?
Think about it. It seems right from this perspective.
Oh,
Still not getting it.
it's a
It's not,
pun.
you don't want
It was a pun. Okay,
Yes.
that was good.
It's on the right of the
Okay,
side.
no, that was good. Okay,
Yeah, but if it's from that perspective, you're
it's okay. Let's
No,
let's
because
move
cosine
on.
would be between there, so on this
Okay.
perspective.
This is good. So here's the deal. The ambiguous case only applies when we have to use the sine inverse to get an angle, because sine inverse can give us either an angle between 0 and 90 or between 90 and 180, both of which are possible for a triangle. Does that make sense? It does not apply when we use cosine law and have to use cosine inverse to get an angle, because the cosine gives you either between 0 and 90, which is possible in a triangle, or between 270 and 360, which is not possible. Does that make sense? So here we go. This is the kind of question you're going to have to watch out for when we do trigonometry in grade 11. Anytime you use sine law, you have to watch out and ask yourself, is it possible that there's two good answers here? Now, sometimes one of them will still be nonsense. If the triangle you started with already had an angle of 110, then obviously you can't have a second obtuse angle in the triangle. Does that make sense? So you'll still have lots of times when sine law still only gives you one possible answer. But you always have to ask yourself, what two angles am I dealing with here? Are those two angles both possible? Does that make sense? You have to draw a picture. And hopefully you're a little quicker with the picture drawing than this guy, who tends to make a little bit of mistakes with it. Any questions about that? Sorry? I lied because...
Conversation in between.
Yeah, it's because I get distracted. It's because I find ideas fascinating, and yours are always so different than mine. And I appreciate that about you.
My ideas are just absurd.
No, well, some of them, and I try to ignore those ones, but others are reasonable. And I like talking about those ones. Yeah, so here's the deal. I'm going to assign you some questions. You need to. You're big kids. But I am going to give you the homework for the weekend. All of next week is just going to be spent talking about doing questions with this type of trigonometry. That's almost true. half-life useful. We're also going to introduce you to the idea of, I'm going to have you do some independent work on something called trig identities. And you're going to do that at first at home yourself, and then the Monday and Tuesday the week after that, we're going to consolidate them and do them in class. But in class, we're just going to be working on using trigonometry for measurement a bit more. These ambiguous case questions. Now I've got to find my ambiguous case textbook questions. How what is?
How long is it on in actual day?
When you pay attention, it seems super long.
The concept of money. Because the concept is think. I have
2 minutes.
No.
8 to 10. Actually, sorry, 8 to 12. Now, these are not, I want to stress this, these are not all ambiguous case questions. Some aren't, some you can try them, but they're all good trigonometry problems. Oh, I'm sorry. Yes. Yes, you. Yeah. I'm going to print it right now for you.
That's the point.